Good evening and welcome to tonight's Pint of Science panel 2021, A Space Odyssey. When we hold events at pubs around Australia, we ensure that we recognise the local Aboriginal and Torres Strait Islander nation, one of many that makes up the continent that we now call Australia. Now that we're holding this event online, and our speakers and much of our audience are streaming in from around Australia, we want to acknowledge all traditional custodians of country, the first innovators and scientists of this land. We pay our respects to Aboriginal and Torres Strait Islander elders past, present and emerging, and recognise their continuing relationship with land, waters and culture. A big welcome to our audience streaming tonight's panel session live on YouTube. Viewers can type your questions as comments on the YouTube beneath the video stream or tweet your questions for the panelists using Twitter with the hashtag PintAU21. My name is Hayley Teasdale and I have the absolute pleasure of being your host for this evening. I happen to be a neuroscientist, which means I'm a scientist who knows a lot about brains, but not a lot about space. I am, however, super into space because it's really cool. And I mean, I assume everyone tuning in tonight is also super into space. So welcome, fellow space nerds. You may be familiar with the sci-fi classic 2001, A Space Odyssey, where intergalactic missions are the norm and people walk around lunar outposts as if it's an international terminal before COVID. Today, in 2021, we haven't quite reached these heights of human space travel. With a boom in private and public funding, it seems that more widespread human space travel is quite likely in the not too distant future. In fact, the newly announced $150 million Trailblazer Program will see the Australian Space Agency collaborate with NASA to support missions to land the first woman and the next man on the moon by 2024, followed by the first humans to Mars. This evening, we're joined by 4 incredible scientists as we aim to discuss the possibilities and challenges of entering this new era of exploration. We'll be asking questions like, how prepared are we for long-term space travel? And what are some of the technical, medical, psychological, and legal considerations for humans exploring this new frontier? Tonight, we'll delve into these questions and you'll be able to ask your own questions through that live stream and on Twitter using the hashtag PintAU21. So I'm now going to introduce all of the panelists to you and then I'll invite each of them to tell you a little bit about their work. First, we have Associate Professor Susana Guatalo from the School of Physics at the University of Wollongong. We're also joined by Dr. Mark Gerblum, Child and Adolescent Psychiatry Registrar and PhD candidate at the University of Melbourne. We also have Annie Handmer with us, who is a PhD candidate at the University of Sydney, and Eduardo Trifoni, who is a space test scientist leading the National Space Test Facility at the Australian National University. Thank you all so much for joining us this evening. It is a real thrill to hang out with this brilliant group of people. So first, I would like to ask Susana to tell us a bit about your work.
Good evening, everybody. I'm the academic director of the Bachelor of Medical and Radiation Physics of the University of Wollongong. And my research is focused to improve radiotherapy treatments, and I also work in radiation protection, including radiation protection of astronauts in missions to Mars. Actually, in 2021, I've been awarded with the Women in Physics Lecturer Award given by the Australian Institute of Physics, because apparently I gave a very impactful research. I gave an impact, a significant impact to the field of physics internationally. And I'm doing a tour in 2021 all around Australia about my research in radiation protection of astronauts in missions to Mars. So thank you for having me today.
Brilliant. Thanks, Susana. And a reminder to keep sending in your comments and questions if you hear anything that a panelist is working on that you're a bit interested to hear a bit more about. So now let's hear from Mark.
Hi, everyone. Lovely to be here tonight. Yes, I'm a training psychiatrist and a medical doctor, but my interests lie in my association with aerospace medicine, and I've been interested in isolation and confinement psychology, which is how, in this context, is how people psychologically prepare themselves, equip themselves, and then survive things like living in a Mars habitat for a long period of time, surviving living in a small confined space. My research is actually translating some of the research that's been done on that into hospitals and looking at how through environmental psychology you could either improve the performance of an astronaut who spends a long period of time in a boring and confined space, something the last year of COVID has given a lot of people a practical experience of. Or in a hospital, when you're stuck in a hospital bed, can we help you to recover or maintain your mental health during that experience better? So yeah, lovely to join you all tonight.
Thank you, Mark. Now, Annie, please tell us a little bit about what you do.
Sure thing. Hi, I'm Annie. It's great to be here. I'm joining you from Sydney. I'm on the lands of the Gadigal people of the Eora Nation. So shout out and paying my respect to anyone who's joining us today, who's also in that region, and also I'd like to pay my respects to elders past, present and emerging. So I'm a PhD candidate at the University of Sydney. I'm in the School of History and Philosophy of Science, which is in our science faculty. And my research is in social theory of science. So essentially, if you've seen that little meme that runs around, I'm one of those people who follows scientists around and asks them questions. And that's basically what I do. But essentially what I'm doing is trying to look at science and technology and its intersection with society, law, and policy, and understand a bit more about that. In addition, I'm on the Advisory Council of the Space Industry Association of Australia. I'm also on the Space Generation Advisory Council on the Ethics and Human Rights Project Group. I'm also a program consultant to the Australian Youth Aerospace Association's Astra program. And I'm also the regional host of the Space Cafe, which is a Space Watch Global thing. And I'm the host and creator of the Space Junk podcast, because I'm just such a space junkie. I had to make my own podcast all about it, which is, great fun. So yeah, I study space scientists and think about them. Very excited to be here. Thanks.
Thanks, Annie. I love space junkie. That is a great term, and I will be using it in the future. Now, let's hear from Eduardo. Please tell us a bit about what you do.
Hi to everybody. I am here in Canberra. I work for the Australian National University, and I am a space test scientist. And I manage the National Space Test Facility, that is a facility used for testing spacecraft subsystems component to the harsh environment of space. So we do simulate on ground what can happen then into space, and we check that the satellites and spacecraft work before they are launched into space. In my background, I worked 20 years in hypersonics, and so I was devoted to the entry phase of a spacecraft into planetary atmospheres. And yeah, that's it. And I'm happy to join this panel.
And we're very glad to have you here. Thank you. Okay, so one last reminder, well, probably won't be my last reminder, but if you're watching along on YouTube, do send in your questions for this amazing panel. But I'm going to get started because I have a few questions of my own. So some people think that we shouldn't spend this whole heap of money on space travel and exploration when we have a lot of problems on Earth that still need fixing. I'm not one of those people, but why should we bother with space travel and exploration? What's so important about it? Anyone want to kick us off? Annie, perhaps you can tell us a little bit about your experience in your research and your perspective on the question.
Sure, I'm very happy to kick us off. So this is actually quite a divisive question. Among the space community, you'll find that most people think that we ought to be going to space and they're very excited about the idea of it. But if you delve a little bit deeper, you go outside the space community, you ask around, and people will say, oh, well, yeah, but why? Why spend that money? You know, there are other concerns around the cultural significance of places. Should we be doing things like asteroid mining the moon, those sorts of questions? I have a lot of sympathy with positions basically saying that it's more complicated than, you know, we have this mission to go to space because we have to colonize it. I actually have a lot of sympathy with the idea that that isn't great rhetoric and it isn't a wonderful idea necessarily. For me, though, there is one overwhelmingly important reason why we ought to be doing space stuff and space travel and space science and space development. And that's just that space is cool. And that, you know, we can, and it's cool, and we should, where at all possible, try to do it in a way that is sensitive and nice to everybody involved, and legal and cooperative and peaceful and all of those good things. But ultimately, space is awesome. That's my formal position on the matter, but I'd be really interested to hear from others on their views. I suspect as a sort of sciencey person, Eduardo might have something to weigh in on here.
Well, I think in general, it's going into space has helped to increase the technology as never before. And so I guess all the things that are around us and that came through after the 60s are coming from the space development. And this is the main reason. So all the dollar invested into this can come back with the technology development probably 10 times more. And I think this is the right point. Then there are other, of course, questions that should be taken into consideration, but and are ethical, and as she says, is related to the colonization, and of course, we should be more than peaceful in this new endeavor, but yeah, we'll see.
We've had a comment from one of our viewers on YouTube that all the money spent on space stays on Earth. And I think that's a really interesting way of putting it. I know that, as Eduardo said, you know, when we have a mission and we really want to get something done, humans can really get it done. And space is one of those interesting examples of how a mission can really speed up innovation and make these new inventions happen much faster. Maybe some new discoveries, even about the human body, happen even faster than they may have happened on Earth. Mark, I wonder if you have any perspectives in your work about some discoveries from space travel that teach us a bit more about humans on Earth.
Sure, I was going to hardly agree with that. I mean, to agree with Eduardo, the space requires us to innovate. You know, and when you put people in a place where you have no choice, but if you want to do this, you have to do it faster or lighter, or you know, people rise to the challenge, and I think that's been one of the places where space has really been a melting pot for some incredible innovation. And so, I mean, I think my field is just full of it. I wonder what medical care would be like if Apollo had never happened. There are so many things that we use every day in healthcare that are that came out of Apollo. I mean, ultrasound, which is like one of the basic imaging techniques we use every single day, was essentially developed. It was the portable ultrasound machine was developed for Apollo because you can't take an X-ray machine or an MRI up to space. And there are so many other aspects of, you know, when you go into a hospital and people being monitored for their blood pressure and their heart rate, all of that essentially started with the Mercury program.
Yeah, it's really amazing how it all comes back around and helps people on Earth. Now, Susanna, did you have something you'd like to add there?
Yeah, I would like just to give some practical examples on how research in space actually help us. For example, in our center, we develop radiation detector, radiation monitoring systems for astronauts, and this research is supported by the European Space Agency. But actually, the same device can be used to check the delivery of radiotherapy treatments. So you see that So something that is developed for space actually has an impact on cancer treatments on Earth. And it's just an example.
Oh, it's a great example, and thank you. So I guess it might be worth segueing to my next question, which was that, you know, we've had a few of these grand missions before. What are some of the main hurdles and difficulties to going back to the moon or to going further and onto Mars? There's technical hurdles, biological hurdles. What are these hurdles that we're facing to get back to the moon and beyond?
Haley, maybe I can connect the last question with the new question. Just for the medical perspective, what we're being asked to do is to get as close as possible to a closed loop life support system. So, you know, the people in their spaceship can reuse their air and reuse their water and reuse their food. And which, you know, when you think about the translational stuff we're talking about before is talking about sustainable human living. You know, if you can have everything in a box and the people are there and everything they need just goes around and you're not producing waste. And the other thing from a medical point of view is how long can you keep a person in good health with very minimal resources? Which is, again, something that, you know, in countries where we don't have lots of health resources, it would be fantastic to be able to help them. So I guess that's the connection with the previous discussion. To answer your question, doing that is, I mean, there's so many different facets of human health that we're trying to address. I'm sure Susanna will talk a bit more about the radiation side of things. But, you know, one of the big challenges is the human immune system doesn't perform as well when we're in space. And, you know, so you're more at risk of infections from the bugs that we bring along. So that's just one of the many challenges that we've got to address in space medicine.
Susanna, would you like to add anything about radiation?
Yeah, thank you, Mark. The fact is that the big challenge here is that it's a long-term mission. Okay, so our longest mission is on the International Space Station, and astronaut can stay there for 6 months. Okay, very well. A mission to Mars. There are various designs for a mission to Mars, but the mission to Mars, in the shortest mission to Mars, would be about 2.5 years, 3 years. So what happens if something happens to the astronaut? It's a 3 years long mission. Space is a very harsh place, okay? The space radiation environment is very harsh. And astronauts can have late effects, like they have an increased risk of cancer, and this is a late effect, but let's suppose that they are invested by a solar particle event, which is unpredictable. They may have acute radiation effects like nausea and vomits, up to die within 1 hour. Okay, so space is a very tough place to live, and this is for the health. Yes, it's for the risk of cancer, and so this is a big issue.
It's a huge issue, and perhaps we can get a bit into the ethics of that a bit later. But I'm really interested to hear from Eduardo about some of the technological hurdles that we face still in getting back to the moon.
So, of course, last time we went to the moon with the humans was in the beginning of 1970s. And so we have no more rockets and technology to go to the moon. And so right now we are rebuilding this technology with upgrading concept that was used for Apollo mission. But of course, it's still a challenge because it's something we have not yet in our hands. And so, you know, from the 70s are now passed about 50 years. It's my age. And so I think recreate this technology is not easy. But going further to Mars is really an incredible challenge. I can tell you that right now we have not the technology to achieve Mars and to come back to Mars. and with the human crew. And so this is something on which we need to work a lot. And the first thing that probably we are considering to address is to create a moon gateway, a sort of space station that will orbit around Moon. And thanks to it, then we can try to launch a mission to Mars. But you can imagine it's not really easy yet. So it's just a first step to a new endeavor.
Amazing. We've still got quite a way to go, but it's all very exciting. Just to pause for a moment, how amazing is this panel? I feel so lucky to be here. I know you all at home must be feeling very lucky to be listening to these incredible people. Please do send in your questions. We have a lot coming through, but these guys are giving great snappy answers, so I think we can get through quite a few questions tonight. So why don't I actually flip ahead and we will take one of our questions from YouTube. So Amy has asked Susanna, how do astronauts protect themselves from that radiation that you were describing earlier? And have there been any recent advances?
Yes, thank you for this question. Well, unfortunately, we cannot reduce the exposure to radiation because actually we want to create a permanent outpost of astronauts on the moon and then a 3 years mission to Mars. Well, there are the first solution is to adopt shielding solutions on transfer vehicles and in planetary shelters. Unfortunately, cosmic radiation can be very high energy, so it's a complex mixed radiation field, so it's very difficult to shield. So we have an option of passive shielding solutions that, said in very simple terms, are layers of polyethylene. Polyethylene is the material that you find in shopping plastic bags and water plastic bottles. And this is not enough for galactic cosmic rays. So I know there is the research in developing magnetic fields surrounding the transfer vehicle, okay? And this, yes, so this is a solution. And instead, when astronauts arrive on the moon or on Mars, the long-term solution is to create the shelters in lava tubes. You know what are lava tubes? Lava tubes are naturally encarved, let's say, tunnels that are left by volcanic activity. And yes, so the astronauts should recover in these shelters because the moon and Mars do not have a magnetic field like the Earth. So there is not a natural protection that we have on the Earth. So also spending some time in exploration on the surface of the moon and of Mars actually poses risks to the Earth because of the radiation exposure. So the idea is to go into these lava tubes.
Fascinating. Wow. Okay, now I've got another question from one of our viewers on YouTube who's asked Eduardo if we could use cars that were developed for space on Earth.
So, of course, we have the first problem that is due to the lack of gravity. So on Mars, there is not the same level of gravity than on Earth, and on Moon the same. And so this is the first problem. But you know that Apollo mission used a sort of cart, and so it's definitely possible. It's difficult, but possible. And on Mars, we have a rover. Indeed, we have more than one rover, but the rover that we have right now on Mars is like a small car. And so it is indeed, it's difficult. It moves very, very slowly. It moves at centimeters per second, but we can do them.
I'm not sure how I'd go parking a Mars rover, but I could give it a shot. I've got a question for Annie. As legislation regarding conduct or ownership for different aspects of space has historically not been signed or followed, how do the panel think that we approach legal and logistical discussions? I thought that one might be a good one for you.
Absolutely. I love a space law question. Well, to begin, I think it's helpful to think about, I might just give a little brief background on international space law, just in case anyone isn't super familiar. So international space law has been around since basically just after Sputnik, but a long time. So we have the Outer Space Treaty, we have a number of other treaties, so a liability convention, a registration convention, a rescue and return agreement for astronauts, and the Moon Treaty. Now, under the Outer Space Treaty, which is very widely subscribed to, I think you can look on Wikipedia for the full list, but I believe even North Korea has signed. Under the Outer Space Treaty, you're not allowed to claim territory. You're not allowed to claim sovereignty over any celestial body. So a celestial body is the moon, it's a planet, it's conceivably a star, but that would be a bit tricky. Whatever you name it, you can't claim it. You can go there and you can hang out. Now, the thing is that actually international law and international space law has historically been followed really quite well. The Outer Space Treaty sets out a framework and general principles by which countries or states are meant to cooperate in space for peaceful purposes. And under that, I think that we do have a legacy of a lot of really good cooperation, a lot of really good collaboration, and by and large, a pretty good track record of people following that and choosing to follow that. We also have non-binding regulations, which people tend to follow as well, around space debris creation and mitigation, which have come about in more recent years. There are challenges emerging, like anything, these things evolve. It's hard to make laws about technology in particular. It's hard to make laws about places we've never been, but ultimately we have to come back to, it's not like tax legislation where you have to follow the letter of the law and find loopholes, and that's what space lawyers do. It's not like that. It's more about, we have general principles, we've got platforms where we all sit down and chat about things. Let's try and proceed harmoniously. And I have great confidence that we will be able to do that in future as well. I hope that answers the question.
It does for me, and I hope so too. Is anyone else from the panel want to add to that one, or are we happy with Annie's brilliant description of the state of play at the moment? All right, now I've got a question for Mark this time from another YouTube viewer who has asked, since you mentioned the human immune system is different in space, how is it different? And is there anything that we could do about that?
That's a really good question. And unfortunately, my immunology days are far behind me, so I can't answer it in a lot of depth. But I mean, there's a few things I can say about it. It's that we have seen that the immune system doesn't work as well. Viruses and bacteria seem to be more infectious in space, and people seem to be more susceptible to infection. The main thing we can do about that is try and minimize how many infections it's possible for them to get. So you'll see with every space launch that the astronauts are isolated for a number of weeks from most of the general population. Only there's a very small amount of people that can directly interact with them, and those people will often be wearing masks. So you're essentially trying to minimize what bacteria or viruses they might be taking into space with them, because when they get an infection in space, it's something they brought with them. So that's the main way that we try and manage that. The other thing is that your immune health is directly related to your physical health. So the more you protect the person through good exercise, nutrition, and there's so much research into how much exercise does a person need in space, which is a lot more than on the Earth, or what is good nutrition. You hear about all these fad diets and all this different information, but when you have people in a space and they've only got one source of food, you get to know A, what people are willing to eat, and B, what is actually healthy for them.
Yeah, wow. Now, I'm going to flick back to a more general question that is open to any of our panelists, but I'm really interested to talk about the role that Australian researchers are having with their contributions to these massive missions and projects. where does Australian science fit into the global picture of space research? What are we good at? How are we making a contribution? I'd love to hear more of what you have to think. Susanna, perhaps you could start with you.
Yes, I mean, as you may know, in Australia nowadays there is the Australian Space Agency, and as you mentioned before, is actively contributing to bring back a man, the first woman on the moon. From my perspective, this is a very exciting period for Australia, and in our what I do, I like to say how I do contribute to space in general. So since my PhD, actually, I develop simulation software tools to describe particle interactions to matter, and then we refine these software tools to do radiation protection of astronauts, because we can't send. Okay, we do not have any astronaut that has been out in outer space for more or less than 1 week. Okay, so not for sure. I mean, I do not consider now the International Space Station. So it's very important to be able to calculate accurately the effects of radiation, okay, in astronauts. And my group, at this stage, we have 2 collaborations with the European Space Agency in this direction. And the second one that we have, I mentioned it before, is to develop a powerful and easy to use radiation monitoring systems for astronauts. So I have to say, as a researcher, I mean, I did my PhD in space science, and then I moved to Australia, and for many years, I mean, it was very quiet. I have to say that the last 2 years have been very, very exciting in Australia for space science.
It certainly is an exciting time. Does anyone else have any examples of Australian science that might be leading the way in the field of space, perhaps?
One example I can give you is our Antarctic division. The Australian Antarctic division are a world leader in polar medicine, but there's so many crossovers between, the Antarctica is sometimes referred to as White Mars, because it's so difficult to live in, and in the middle of a blizzard, if you walk outside, you could die just as easily as if you walked outside on Mars. And Australia's rural and remote medicine, and they're taking those capabilities and using them in Antarctica, has produced some really incredible stuff that's world leading. So there's a lot of back and forth between what the Antarctic division does, and then they speak at a lot of space conferences about what they're developing.
Yeah, brilliant. So Australia has strengths in that we are close to Antarctica. We've done a lot of Antarctic research, and we're pretty large ourselves. I'm sure there's enough remote places in Australia that might teach us a few things about what it's like to be living in a remote place. Annie, did you have something to add?
Yeah, I thought I'd weigh in just with a little plug for the United Nations Committee on the Peaceful Uses of Outer Space, which might be the nerdiest thing I've ever plugged. But so Australia is quite good at remote mining, so doing mining operations from a distance and developing the technology, the robots, the computer systems, the communication systems to enable that, which means that we've also been working in various ways at various places on remote mining capabilities that could be used in space. And so, of course, there's all sorts of views on this, but one of the things that we can look to do is mine resources to support a scientific station, for example. So that's a really positive thing that can be done. The shout out for the legal subcommittee meetings is next week. The United Nations Committee on Peaceful Uses of Outer Space Legal Subcommittee will be meeting, and this is very exciting. And they'll be talking about the use of space resources in this forum. So it's international discussions, and the discussions are being co-chaired by an Australian. So that's by Professor Stephen Freeland, who represents Australia in partnership with our diplomatic relations and so on at these meetings. So it's a really exciting moment for Australia in that we're contributing both technologically to the discussion, but also on the legal and regulatory side equally. And I think that it's a great moment for us on the world stage.
It is a great moment. We love seeing an Aussie with a seat at the table, especially if something as important as this. So that is really great news. We've had a question from Clarissa on YouTube, and this is a question that I've thought about a lot, so I'm really keen to hear your answers. Do you think our panelists think that one day people with a disability will be able to travel to space? It would be wonderful if space travel could be equally accessible to all. Now, Mark, perhaps you'd like to start us off. I'm not sure, as the medical scientist in the room and doctor, on what you think of that question.
Sure. I imagine that is an inevitability. I think it's just a question of where the technology's at, how safe it is, and then you move from in the days of Apollo, when there's you have to find the best of the best, and it's really experimental. And then, but what we're seeing, we're seeing commercial companies getting ready to send people into space. First for the government, and then space tourism is the next step. And I think as these things we get better at refining these technologies, and we open up that accessibility further and further. I think it's an inevitability.
Yes, with commercial space travel, that you think that could be where it comes in for people with a disability to travel to space, or do you think that there's an opportunity for an astronaut with a disability, perhaps?
I think if I can add one thing, that in the near future, going into space should be as easy as taking an airplane right now. And so at that level, people with disabilities will have access, I guess. And hopefully very soon.
Well, Annie?
Yeah, so actually we're making progress on this, and I think it's really great that space is becoming more inclusive and more accessible. Of course, historically, especially in the US context, it was very much that things were designed for men, and then slowly we've accepted that women might also be able to go to space, and that's cool. And alongside dogs and rats and monkeys and all sorts. So it's a slow process. But actually, recently, about 3 months ago, the European Space Agency put out a call for astronauts to apply, prospective astronauts to apply who have disability, who live with disability. So that's a really exciting step from a government standpoint of an agency with major power saying that everybody is equally able in this respect, and that technology is advanced to such a stage that it's really, there's no excuse anymore. So that's really exciting, and hopefully others will follow, and we'll see more inclusivity of all people when it comes to being astronauts. Although that said, it's still really hard to become an astronaut, no matter who you are, no matter where you are, and no matter what things you live with. It's actually incredibly difficult. So I cannot wait to see who we get in that role.
Amazing. I love the positivity too, and especially thinking about how soon this could all come to fruition, that we could be traveling into space as easily as we take an airplane. Perhaps when it was easier to board an airplane, but nevertheless. We have a question asking, and this would be a question for Mark, I think, but are the mental effects in space shuttles the same as having cabin fever, like you might have in a submarine or something similar to that?
There's similarities. I guess, like most things, the answer is yes and no. The impact of being in a small confined space, wherever you are, is going to be stressful. There are certain things that are particularly stressful about being in space, such as your body adapting to microgravity. There's a portion of people that get space sickness when they're because you can't really tell what's up and what's down, and that can be really nauseating. But yeah, I guess there's some things that are the same as, say, being at home like in lockdown during COVID. And then there are some things that are specific to being in space that people adapt to.
We've got a question for Eduardo. I think might be the best person to deal with this, but please feel free to handball at Eduardo if it's not. But what are the best approaches to dealing with space debris or space junk? Will the world one day reach an aviation traffic styled legal regime, or is it best to just focus on the technical solutions?
So indeed, is not having space junk. This is the question. And so have a controlled demise of the spacecraft at the end of their life cycle. This is the best approach we can have. And this is something on which almost all the most important companies are working, and agencies are setting up constraints. And so basically, the spacecraft should have enough fuel then to start this controlled demise. And that's the only way. Of course, there are current problems that need to be addressed. There are a lot of researchers that try to work out a solution. It's not really easy, absolutely not easy.
No worries. That's very interesting. I have a question now for Susanna. Are the astronauts on the International Space Station being exposed to high radiation? And does NASA have regulations on radiation risk?
Oh, very interesting. Thank you for this question. NASA has regulations, so there are limits. So astronauts can have a mission on the International Space Station for 6 months. Okay, there are career limits, and these limits are respected. Okay, for the astronauts of the International Space Station. So the NASA defines the limits based on the gender and on the age of the astronauts, because the effects of radiation depend also on these parameters. So the younger is the astronaut, let's say the lower are the exposure limits, okay? And these limits correspond to a 3% probability of death due to cancer induced by radiation. So it's a 3%, which is respected for the International Space Station. Now, the problem, let me add, because I think it's of interest in this context, is that for a human mission to Mars of 3 years, given our knowledge of the radiation environments, of the effects of radiation in biological media, okay, in humans, we do not know if this cancer risk in a mission to Mars is 3% or 20%. So now, by an ethical point of view, you see, by a scientific point of view, we do not know at this stage. If we send the astronauts to Mars, which is the cancer, to die of cancer, the probability is 3% or 20%. By an ethical point of view, I think this question poses, this problem poses questions.
It's a big problem. We've got a related question I might just throw to you as well, Susanna, which is, we hear about companies like SpaceX, putting a lot of work into, the technical aspects of what they're doing, the physical hardware. But do they do research into these human aspects of space travel in those kind of companies as well?
Yes, absolutely. There is research, and there are many experiments, for example, on the International Space Station, to measure the dose, to measure the effects of radiation, to measure the dose given by the cosmic radiation in astronauts. So the International Space Station is a fantastic lab, let me say, where many technological problems, where many health problems, as we said before, can be solved before we send human beings to outer space, let's say, in more critical missions.
Excellent. Good to hear. So we've got a question. I'm actually not sure who might be the best person to answer it, but let me put it out to the panel. Hello from India. Do you notice a change in time as we know it in hours, minutes, and seconds when you're in space, especially as one isn't exposed to sunrises and sunsets? Does anyone want to take that question?
Sorry, may I interpreted the question is because a person on the moon, for example, experiences, let's say 2 weeks, of Earth, let's say in the day and 2 weeks in the night, if this person is on the moon, for example, is this what you mean? Is this what is meant? If it is.
Yeah, I think they're saying, well, just anything to do with how you experience time or day and night, or I'm thinking even rhythms or how you regulate your sleep patterns when you're in space compared to on Earth.
Okay.
So basically, if you are on the International Space Station, you make an orbit each 90 minutes. And so, of course, you have during this orbit 1 day and 1 night. And so you can imagine each 1 hour and a half, you have 1 day and 1 night. It's really tough. And this is part, I think, of research of reaction of the body to this kind of luminous. And so, yeah, I don't know really in a travel to Moon or to Mars how it does change. But probably orbiting around Earth is very tough for this reason. Yeah.
I was gonna answer that slightly differently, but I left it to the physics people because it's not really my area. But my understanding is that further away from the gravity well of the Earth, that time actually passes slightly differently. It's slightly slower on the Earth than it is in space. Correct me if I'm wrong.
Yeah.
Susanna's nodding, so I think you're on the right track.
This is me digging up, my physics from 15 years ago.
So even though we're experiencing changes in the light that we're exposed to and things like that, time actually may be a bit slower. Is that right?
It's because of the gravitational field of the Earth. This is because of general relativity. And actually, yes, the time, let's say, the perception, the time, let's say, changes. Honestly, I do not know which are the effects of this on the astronauts' Earth. So...
No, it's a good question. It's got us thinking, got us chatting. That's all good.
I was going to say the other side of that is I think, Hayley, you mentioned the circadian rhythm. And there's actually researchers in Melbourne, Dr. Tracy Sletton and her group have worked with the Antarctic division, looking at, because in Antarctica, you have months of nighttime or months of daytime. And there's similar work that gets done on the International Space Station. So the astronauts wear a watch that kind of says, how long they've been asleep each day. And what you notice is when you don't have a consistent source of light for the body to synchronize with, people's sleep patterns change. So each day they sort of go to bed a little bit later and wake up a little bit later, and suddenly they find themselves, on a completely different day-night cycle to some of the other crew members. And they've seen that in some of the analogs. So in the Mars 500 experiment, I think two of the pseudo-astronauts completely flipped around their day-night cycle. And in the NASA Caves studies, where they have a whole bunch of people, I think there's a group that just came out from a 40-day NASA Caves study where they basically lived underground in caves with no natural light, and they study how the body reacts to it.
Wow. Now, I had trouble getting participants for my research experiments that were just happening on university campus. I can't even imagine trying to get participants for that study, but that's incredible, and teaches us so much about the human body. Now, I have a question on a bit of a different note about the ethics of travel to space when we don't know the full extent of what is, potentially happening to the human body. We've heard a few different things about radiation and about the immune system, but are we ready for commercial space travel if we don't quite know everything about how the human body and the human experience is in space yet? Annie, would you like to weigh in on that one to start us off?
Absolutely. I was going to say the comment about going for days on end without natural light is quite familiar as a PhD candidate. So I feel we've all experienced it, and you do become just slightly unhinged through that process from a little bit dissociative from life. Yeah, look, on the subject of ethics, it's a really great question. Ultimately, it's actually a question that isn't just an academic one. There's legal parameters to it as well. I mean, companies have to guarantee a certain level of safety to an extent. When the government is the provider of the space service, there's a slightly different expectation than if you buy yourself a ticket on board some trip to outer space and you're expecting to come back again. Let's say you hop on a trip to Mars and you set up camp there, and then you decide that you want to come home. I mean, this is something that's happened during COVID as well. What are the Australian government's responsibilities to you as a citizen to try and get you home? Is it possible, even technologically, to do that? And if something goes wrong, if you break a leg, if you have some sort of injury, if you have an interpersonal dispute, if there's some sort of nasty allegation going on, ethically, do we have a responsibility to people that we're sending into space to think about these things? And even if they consent, to what extent can a person consent to going to a place they've never been to before? I mean, is that informed consent at that point? And the other thing I just want to throw in really quickly as an ethical point is when it comes to the idea of forming settlements and having families on Mars, for example. Now, if we send biological women to Mars, the expectation may be that they will bear children. And at what point does the issue of consent come in there? Can they say, actually, no, I don't want to have children, having got to Mars? Have we stipulated in a contract that they are required to do so, and with whom they're required to do so? And what rights do we have ethically, legally, socially in that case as well? It's a really interesting problem. I don't have an answer. This is the joy of doing the sort of thing I do. I just sort of say, this is interesting, and then throw it to someone else. I'm sure that the doctors in the house will have something to say on this matter as well, because medical ethics is its own field of joy.
Annie, I was just going to say, that idea of would you have a choice just sort of blew my mind. I'd never actually thought about. That's a big question.
Sounds like we have a lot of questions to answer before we get there, but we've got the best minds working on it, right? Right, so we have one final question to all our panelists. Given your expert knowledge and in-depth experience researching space, we have a hard-hitting question to wrap tonight up. Do you believe in aliens? Annie, I'd like to start with you, but I'll be calling upon each of you for this one. Just a quick, do you believe in aliens?
Absolutely, I believe in aliens. The real question is, do the aliens believe in me? And I'll leave you with that. Thank you.
Amazing. Mark, how do you feel about aliens?
I think once we thought that that the sun revolved around the Earth, because that made sense from our sort of human-centric point of view, I think, the galaxy, the universe is so big that the idea that we're the only ones here is just a tad egotistical. So I'm definitely in the pro-alien side with this one too.
All right, I've got 2 votes for aliens. Eduardo, how do you feel about this strange question?
So I feel comfortable now. We have the proof that each star that we see in the sky it's like a sun and so around each star there are at least 5 planets. And so if you go in the outback and look at the sky, you can just realize how many billion, I guess, of stars are there, and so how many billion of planets are there. And so I think this is the reply.
I like it. It's a good answer. Susanna, what about you?
I think I'm positive. I mean, I think I hope actually that there is alien life, and I hope that we live enough that the alien life will be discovered while I'm still alive, because that will be so mind blowing, and it will open up again a new revolution. It will be a revolution by a cultural point of view. So I hope, for sure, I hope.
Amazing. I feel like we're seeing the curiosity of scientists coming out here, as we all want it to be true, because then we can learn all about them and it would be amazing, right? It gives us even more work to do.
But I expect that they are small microorganisms.
Micro dinosaurs would be awesome. I would not be against that.
Haley, do you believe in aliens?
Smaller than the alien, so it's good. Amazing. Okay, so that brings us to the end of our wonderful discussion. Thank you so much to all our panelists tonight. We do actually have another panel on tonight for Pint of Science. It is in 1 hour at 8:30 Australian Eastern Standard Time. The theme is Thoughts for Food. What are we going to eat in the future? And features panelists developing genetically modified crops and petri dish grown meat. Grab something to eat and join along to find out what you might expect to see on your plate in the future. I want to give a big thanks to all of the Pint of Science volunteers who've done a huge amount of work in the last month to pull these Pint AU online events together, including our small team of Pint panel organisers who have done an excellent job. Pint of Science is supported by volunteers. If you're able, please leave a donation on the Pint of Science Australia website to help us keep our events running. And again, thank you so much to our panelists. A big thank you to our audience. What great questions we had sent in all through the panel this evening. And Pint events in any format are all about connecting over conversations, and it has been an absolute pleasure interacting with all of you online this evening. Let's keep the conversation going online. Thank you very much, and good night, everyone.